Bismillah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullah.
Let me. Okay, inshallah. So hopefully everyone is doing well. This is our final class in week 14. So alhamdulillah, after 14 weeks of um, classes in this semester, we have reached the end of the scheduled 14 weeks. So today's session, we will have the final chapter in the syllabus that is covered in the syllabus, which is chapter 8 regarding friction. Now, actually, if you look at the textbook, if you have the textbook, if you look at what is covered in chapter 7 as well as chapter 8, what we cover in the syllabus is only like a small portion of the chapter each, right? So for chapter 7, we only covered how until and you will be tested only until computing the normal force, shear force, the moment, the internal loadings, and you will not be tested on drawing the diagram, etc. Even though that will be necessary in later courses. Similarly with friction, so you will not be tested on, I think, friction of an angular surface, etc., that you may find in the textbook, but it is not included in our syllabus for the 14 weeks course. Anyway, so given that both of these, chapter 7, of course, chapter 8 as well, will definitely be part of the questions in the final exam. I really hope that you really understand how to solve any given questions in this chapter that may be asked in the final exam. Um, so unlike okay, in term of the exam, in term of the final exam, I think I've mentioned in the last session. I think I mentioned that for chapter 7, the question will be quite straightforward in the sense that it will ask something like in a beam, the normal force, the shear force, the moment. But of course, to get to that point, you have to know other topics as well, including distributed loading, including finding the support action first, right? So that's chapter 7. But for chapter 8, the concept of friction is straightforward. The thing is, you have to be able to draw the correct free body diagram before you can correctly solve the problem. And the problem in friction can be several type of questions. If you look at the textbook as well, there may be some question with regard to like a box or something where you have the possibility of two possible scenario or more, right? Either tipping or slipping. That's one thing that you need to be able to understand. Second, if there are multiple point that you have friction, right? So I think in the if you have like, I don't know, a car with two different wheel which have friction either on one of it, on one of the wheel or on both wheel, etc., depending on what the question is saying. Or if you have something like a ladder that is resting on a wall and also on the floor, you have to be able to detect where the friction is, whether it's both point or only on one of the point, etc., right? So the diagram is one thing, the sentence in the question is another thing that you have to be able to understand when this question says something. right? Another thing that you have to really understand is the impending motion, where the question does not necessarily state impending motion. It can say what is the minimum force, what is the maximum force. So normally those kind of word means at impending motion, right? Meaning that maximum, meaning that anything above that, something else already happened, or minimum, anything below that, you will not reach equilibrium, for example, right? So make sure you are well versed on different type of questions. I think in the lecture we may have covered this example, and into the tutorial video I have tried to cover various type of example that have come out before, but take a look at the textbook as well in case there are other type of question that can also be asked, and make sure you know what to do and how to deal with those things. Now for today, the quiz as usual at 9 a.m. It will be officially our final quiz, and afterwards I will post the carry mark, inshallah, after I have finished all the marking. And of course, because we have the 2 weeks buffer, in case anyone feel that that is necessary to request for anything additional after this, if needed, it can be discussed. What else? I hope, because I have posted the survey in the Telegram just to know whether and how many will be taking exam where, right? Especially if you are taking the exam from outside of Malaysia. We want to understand the time difference and if there is anything that we should be aware of. So respond to that. Other than that, I think I have also put an information of this is outside of the course, but there will be a sharing session that I think can be beneficial for many of you. So if you do not have anything that prevent you from joining, it is advised that you join, and of course you can ask question as well. If you are having an ambition to become an engineer and successful engineer, but more to work with companies in Europe, etc. If you have that kind of ambition, that sharing session may be beneficial for you, right? I think I have announced this in the Telegram group, right? Other than that, as usual, any question, anything? Yeah, another thing, I think for friction, one different than all of the previous topics that we have covered is in terms of the direction of friction in the free body diagram. Now, in support reaction, there are many type of support that require you to assume the direction, and if the answer is positive, then the assumption is correct. If the answer is negative, the assumption is meaning it should be the other way around, right? So that is valid for pin, for collar, etc., right? But for friction, it is not about assumption. You have to know where the direction is, because when you draw the opposite way, it doesn't it doesn't happen like before, right? Meaning that before, if you have a pin support, if you assume in one direction, the outcome will be either you get the correct number with positive, meaning that direction is assumed correctly. If you get that number but negative, it will just mean the other way around. But for friction, if the friction should be in this way, you draw in that way, your answer will be different, right? So you cannot assume. You have to know exactly which direction it is, because wrong direction will, meaning your answer, the number is totally different, right? So make sure you really understand where is the direction of the friction, right? Sometimes that from the drawing you can know. Sometimes the drawing is not enough. You have to read the sentence, right? Because there are several possibilities that can happen, which results in different direction of the friction. right? Wallahu alam. So those are among the things that you really have to understand. And anything, if anything, as usual, I'll be here on standby to address any of your questions. Wallahu alam. So, yep.
Assalamualaikum, sir.
Waalaikumsalam.
I have questions, sir, regarding internal force. Let's say there is a beam, right, and then let's say there's a 6 kilonewton is acting on force A. So and then the question asks us to find the internal force at point A. So if we draw the field body diagram, do we need to include that 6 kilonewton?
Meaning that force is on that point.
Yes, yes.
Okay, in that kind of question, normally the question will have to specify whether the force is to the right or to the left, meaning just to the right or just to the left of the point. Meaning that um, because when you cut the the beam, for example, right, it becomes two part, meaning on the right or on the left, and the drawing have to be corresponding, meaning that you have the normal, the shear, etc. Is the opposite way, right? So the force can be only on one of those two diagram. It cannot be on both because then it will be duplicate. So normally the question will say something like um, the force, whatever kilonewton, then 6 kilonewton, for example, is just on the right of that point, for example. Uh, so if you draw the diagram on the right, then it will be included. If you draw the diagram on the left, it will not, for example. Is that clear? Or is it understood or not understood?
Yeah. Okay, understood, sir. Thank
Yeah.
you.
Okay, welcome.